Namaskar, welcome back to Math Circles. I am Radhika, and in the previous video we talked about Cauchy sequence and also two theorems related to that. And today we are going to take another theorem related to Cauchy sequence, and it is also one of the important theorems, and it is a named theorem, and the name is Cauchy general principle of convergence of sequence. Okay, so let's see the statement. A real sequence is convergent if and only if it is a Cauchy sequence. I guess that statement makes the analysis very easy, that if the sequence is convergent then it would be Cauchy sequence, and if it is a Cauchy sequence, that it is for sure that's going to be convergent. Okay, and now the second statement, how can you redefine this? That a necessary and the sufficient condition for the convergence of a real sequence xn is that for each epsilon greater than 0 there exists n naught belongs to capital N such that mod of xn plus p minus xn is less than epsilon for all n is greater than n naught and where p belongs to n. So you can use any which way, and this is nothing, it's just an expansion form of the definitions of Cauchy sequence or a convergence sequence. That's it. There is no such difference between the statements. Okay, so let's see the proof of the first theorem. So in the first theorem, the statement says that a real sequence is convergent if and only if it is a Cauchy sequence. So first let's consider that our real sequence is xn. This is our sequence, and this sequence is what? Convergent. Okay, this sequence is convergent. So what is the definition of convergent? If it is convergent, that means limit n tends to infinity, xn is going to be L, right? Or you can say for each epsilon greater than 0 there exists an n naught such that mod of xn minus L is less than epsilon for all n is greater than equal to n naught, right? This is a definition for when the sequence is convergent. So this. Now we need to show that it is a Cauchy sequence. Cauchy sequence, for the definition of Cauchy sequence, you need two elements from the sequence. You need to find the difference between them, and the difference between them should be less than epsilon, right? So let's take any two elements from this. Like just simplify mod of xm minus xn. Let's see what happens if we find the difference between these two elements of the sequence. So what I'm going to do is xm, I'm just going to subtract L and L add and minus of xn, and that's it, right? And we know that from the triangular inequality that this is going to be less than equal to mod of xm minus L and plus mod of L minus xn, right? And if mod of xm minus L is less than epsilon, then mod of xm minus L will also be less than epsilon. The reason xn is any general term on the sequence, right? तो if this is in general term, तो xm भी क्या होगी आपकी? कोई भी एक term होगी that is in the sequence. It means आप इसे क्या बोल सकते हो? तो ये भी क्या हो जाएगा? Less than epsilon and plus epsilon, and this is less than epsilon to epsilon. Now it is coming in the form of 2 epsilon, and आपको मैंने लास्ट वीडियो में भी बताया था कि हम इसको क्या मान सकते हैं? एक कोई और कांस्टेंट वैल्यू मान सकते हैं, that less than you can say epsilon dash, और यू कैन डू वन मोर थिंग कि आप यहाँ पर क्या ले लें? एप्सिलॉन बाय 2 ले लें. अगर इफ यू विल टेक एप्सिलॉन बाय 2 हियर, सो इट विल गिव यू एप्सिलॉन बाय 2, सो इट विल डायरेक्टली कम टू एप्सिलॉन. सो डिड यू नोटिस द डिफरेंस दैट हियर व्हेन इट इज एप्सिलॉन बाय 2, सो डेफिनेशन पे पहुंचना क्या हो जाता है? बहुत ईजी हो जाता है. So that way you can easily reach the definition without considering any other variable. Okay, so now we have come to our definition that mod of xm minus xn is less than epsilon for all what m and n is greater than equal to n naught. Okay, so now you can see that when we took that sequence is convergent, we have reached that it is a Cauchy sequence. Now we need to go the backwards. So I hope the first part is clear to all of you, and let's start the second part. So before moving to the second part of the theorem, let's see that कि जो हमने इसका सेकेंड स्टेटमेंट का जो हमने सेकेंड पार्ट लिखा था वो हम कैसे प्रूव करेंगे. सो आई विल गिव यू द हिंट दैट हाउ वुड यू प्रूव दैट इज लेस देन एप्सिलॉन यू नीडेड टू प्रूव, राइट? सो आई विल डू द सेम मेथड दैट आई वाज डूइंग अर्लियर, दैट आई विल जस्ट ऐड एंड सब्ट्रैक्ट L, and then I'll apply the triangular inequality mod of xn plus p minus L minus L and plus mod of n minus xn. Again this is what epsilon by 2 plus epsilon by 2 and less than epsilon. Okay, so we'll follow the same process. It's just that कि जो terms की representations है that has been changed. Okay, now let's see. अब हम इसका reverse part, converse part करते हैं. Then that is, if a sequence is a Cauchy sequence, then how would you prove that it is a convergent sequence? Okay, so let's consider, हमने कोई एक sequence consider कर लेते हैं xn, and let's see that it is, if it is a Cauchy sequence. So this is the easiest part of this theorem, I'll say, because we'll just use the definitions and we'll just use the statements that we have already done to prove this converse part. Okay, so there is no mathematical part involved or addition subtraction involved. We'll just use all the theorems here. So if it is a Cauchy sequence, and we know that Cauchy sequence is bounded, right? We know that what? Cauchy sequence is what? Bounded. And we also know that if a sequence is bounded, then it has a subsequence that would convergent. Every bounded sequence has a convergent subsequence. So bounded sequence, that means it has convergent subsequence, and let's see, it is the converging subsequence is converging to L. Now the Cauchy sequence is bounded and it also has a convergent subsequence. Now Cauchy sequence has a convergent subsequence, and we know that if a Cauchy sequence has a convergent subsequence which is converging to L, then the Cauchy sequence is also converging to the same limit, right? So now come to the square one, that the Cauchy sequence is going to be convergent, and it is going to be convergent at the same limit or the same point as its subsequence was converging. Now, so the second part is done, that every Cauchy sequence has a the Cauchy sequence is convergent. So both the parts are done, and I hope आपको दोनों parts बहुत अच्छे से समझ में आ गए होंगे. And in the next video we'll take the next theorem or the next topic. Let's see. And even if you have any doubt in this theorem, you can write it in the comment box. And if you did understand it, please like, subscribe and share it with your friends. Thank you so much.
Please like, subscribe and share it with your friends. And for latest updates, click on the bell icon. Thank you.